Here's something almost nobody knows. A rudder does not turn a ship. Not directly, not the way most people think. The rudder is just the beginning of a chain reaction, and what actually turns the ship is the water itself. Here's how it really works. First, understand what you're asking physics to do. A ship like this weighs 200,000 tons. It has no wheels, no road surface, nothing solid to push against. And the rudder, this blade at the back of the ship, is incomparably smaller than the hull it's supposed to turn. So how does something that small move something that large? When the helmsman turns the wheel, the rudder deflects to one side. Water flowing past it generates a lift force, like a wing underwater. That force pushes the stern sideways. But here's where most people stop thinking. That rudder force is not strong enough to turn the ship on its own. The moment it creates around the ship's center of gravity is too small. So what the rudder actually does is introduce a drift angle, a tiny tilt between where the ship is pointing and where it's actually going. That drift angle is everything. Because now the ship is no longer moving in a straight line. It has what's called a sway velocity, a sideways component of movement. The hull is now pushing into the water sideways, and water resists. That resistance, the inertia of the water particles pushing back against the hull, creates a massive force along the length of the ship. Half of that force acts at the stern, half acts at the bow. And this is what actually turns the ship, not the rudder alone, the hull. The rudder starts the process, the hull completes it. The rudder is the trigger, the water is the weapon. And this is why rudders have a counterintuitive behavior. When you turn the rudder to starboard, the ship briefly sways to port first before the full turning force kicks in and the bow swings right. The sway is small, barely felt, but the physics is there. But this entire mechanism depends on one thing being true. The ship must be moving. No speed means no water flow past the rudder. No flow means no lift force. No lift force means no drift angle. No drift angle means no sway. No sway means no hull force. And no hull force means the ship goes straight wherever it's pointed. This is why docking is the most dangerous part of any voyage. The ship is slowest, the steering is weakest, the consequences are closest, which is why modern ships don't rely on the rudder alone. Bow thrusters punch sideways through the hull. They generate their own sway velocity with no forward speed required. And the most advanced ships go further still. They use azimuth thrusters, propulsion pods that rotate 360 degrees. Point them in any direction the ship moves, in any direction. No rudder, no drift angle required. Direct force in any axis. Most people think ships turn because someone turns a wheel, but the wheel just starts a conversation with the water. The rudder whispers. The water answers. The hull turns. The ship is not fighting the ocean to change direction. It's using the ocean to change direction. Every turn a ship makes is a negotiation between mass, momentum, and fluid mechanics. The rudder doesn't move the ship. It moves the water, and the water moves the ship. That's not steering. That's applied physics at 200,000 tons.